Assalamu alaikum warahmatullahi wabarakatuh, dear students. In our previous sessions, we have worked on the hypothesis testing, and particularly we work on the right tail test, where you have learned how to use the t-statistic, dear students. And you know that the t-statistic is used when the sample size is less than 30 and the population standard deviation is not known. But when the n or the sample size is greater than 30 and the population standard deviation is known, then the appropriate test is z-statistic, dear students. Okay, we had an example of a marketing analyst where he was interested to know whether the users when visits the website stay on the websites for more than 5 minutes or not. So for this claim, we had a data of 12 customers, right? Okay, it's 12 customers and how much time each customer stay on the websites. So here the sample size was less than 30, dear students. And you know, if the sample size is less than 30, then the appropriate test is t-statistic. And also the population standard deviation was not known, then we have computed. Okay, for test statistic, once again, we need the x bar and the mu, standard deviation, all these information. And if you do it manually, you have to have all these information. So we computed the mean and the standard deviation. And the hypothesis for our situation, before everything, when you have this example, then you should develop your hypothesis. What is our null hypothesis? The null is that the mean or the average time the customers stay on the website, that is 5 minutes or less. But the marketing analysts claim that no, the customer stays for more than five customers stay for more than 5 minutes on the websites. So this is our alternative hypothesis, dear students. Okay, for testing this hypothesis, we are using these data sets, right? And particularly the t-statistic, okay? Okay, for that you need significance level in the degree of freedom and critical value. And once you have all these information, simply put all the information, plug it here in this function, and you'll have t-value. And once you have t-value, then you should compare it with the critical value. If the t-value is greater than the critical value, then you should reject the null hypothesis. Why? Because we have sufficient data, we have sufficient evidence that the null hypothesis is not true. In the favor of that, we are accepting the alternative hypothesis, dear student. Okay, since the t-value, if you remember, is 4.36989, we discussed is greater than the critical value, we are rejecting the null hypothesis. But all what we have done in the previous session, dear student, it was manual. And how to do it in Excel? Do we have any function in Excel? Yes, we have a way for in Excel. Okay, if you do not use this function in all this process to find out critical value and degree of freedom, just straight away we have a simple and easy way in Excel, okay? Okay, just click on data here and we have data analysis. And if you do not see the data analysis here, just right click here and click on the customize ribbon. And just within the add-ins, we have analysis toolbox and just click on the go, and after that analysis toolbar. Click on this and it will appear here, dear students. Okay, now when you click on the data analysis, here we have two tests, okay? We have two sample t-test for two sample, t-test for two sample, but we do not have t-test for one sample since we, okay, Excel is not designed for one sample, okay? So that's why we are using any of them, but for that we need to trick here, okay? We have some trick. We should create one another sample. I'm just creating a dummy variable and just put here 0 0. Just we are tricking here, telling the Excel that yes, we have two samples, okay? Now just click on the data analysis and click here on the two samples and use this one, okay? Two sample, t-test two sample assuming unequal variances. Double click this and just click on the variable here. Check this is the first variable we have. Then click here and take the second variable. This is our second variable. Indeed, this is not our variable, just this is a trick, dear students. Okay, what is the hypothesized mean difference? Okay, this is the hypothesized mean, the claim we have. Okay, the null hypothesis claim is 5, okay? So we call this the hypothesized mean, and this is 5, just 5. And then yes, I'm just using the label because in the range I've taken the labels. Okay, what is the alpha? The alpha is 0.05 here. Okay, just what is the output range? Select the output range. I'm just telling, give me the output here. Okay, dear students. Okay, this is the information, just some extra information here. We do not need it. This, and Okay, in this output, the informations we need is the, yeah, we have mean, the mean value is the same. You can see we found it here. Simply, this is the mean value. And the t statistic, this is something important. We have t statistic and the critical t critical value. This is the critical value of the t. Okay, dear students, if you do not use manual method, then you can use this output here. The t statistic is 4.36 in the t critical region. This is the critical value we found it here. Okay, just compare both of them. If the t statistic is greater than the t critical value, we are rejecting the null hypothesis. One more additional information, dear student, and that is p-value. Okay, what is p-value? This is another criteria. If you just try to use the p-value, right, then you should compare the p-value with this the level of significance level, right? If the p-value is less than significance level, then we are rejecting the null hypothesis. Look, the significance level is 0.05 and the p-value we have is 0.005. This is way less than the significance level. Okay, this is another criteria. One way is just you use the critical region, right? Compare the t statistic within the critical region, and the second way is just you compare the significance level with the p-value. If the p-value is less than 0.05, you should reject the null hypothesis. Okay, this is the p-value given in the output. What if you just try to find out the p-value, use the table, dear student? Yeah, for the p-value, if you just try to find out the p-value using the table, then the t statistic should be standardized, converted into p-value, and for this you can use the table. So just go into the table and check the 11 degree of freedom where the 4.36 lies. So in our example, in the 11 degree, the 4.36 is somehow closer to this value. In the p-value is 0.0005. So that's why you can say the p-value is here 0.0005. So we have the p-value of 0.0005. It's mean this p-value is less than the significance level 0.05. That's why we are rejecting the null hypothesis, right? Okay, dear student, this was all have to use Excel for this function. Now just we are using the left tail test, dear students. And the left tail test, we have one another scenario. A store manager of supermarket chain wants to verify if customer satisfaction scores have dropped below the acceptable level of 7.0 on a 10-point scale. They randomly survey 10 customers and collect satisfaction scores. Okay, dear student, the store manager is worried and he thinks that the customer satisfaction level are that dropped significantly from 7.0, which was previous, right? So on the 10-point scale, now he's just worried that the customer satisfaction level drop, and that just checking whether it really drop or not drop. He has just taken the sample through survey from the 10 customers, right? This is 10 customers. Now, what is the null hypothesis here, dear students? Simply, null hypothesis, we say the mean value that is equal or greater than, right? That is equal or greater than, for example, 7. In the alternate hypothesis H1, we say the mean value is less than 7. Okay, dear students, very simple how to develop the hypothesis. Okay, the store manager is just interested to know whether the mean value of the customer satisfaction level dropped or not. So that's why the claim or the alternative hypothesis that mean value is less than 7. Okay, and the null hypothesis where the equal sign is always that that's the mean time is equal to the mean satisfaction score is 7 or greater. Okay. Now, for testing this hypothesis, dear students, we are using the left tail test. Why? Because the tail is just coming in the left side of the normal distribution. Okay, what information here need once again? Okay, first you need to find out the mean value. Okay, simply the mean, for the mean value, just use the average and take all the data in the range. This is the mean value, and then standard deviation. Okay, we have stdv.s and take the standard deviation simply. Okay, and what is the significance level? We are interested to know about significance level, and that is yes, again 0.05. And next, in t statistic, if you use it manually, And then we need to know about the degree of freedom, dear students. So in our example, the degree of freedom, we have the total sample of 10. So the degree of freedom, you can say that is how much? That is 9 simply. Once you have these two values, then from the T distribution table, you can find out the intersection value, and that is the critical region, the critical value. And have to find out, just stick in the degree of freedom 9 and 0.05. Okay, degree of freedom 9 and 0.05, and this is the value 9, 1.833, dear students. This is 1.883, dear student. Okay, dear student, since this is the left tail is, and you know that the normal distribution that is symmetrical, and if you find out the t value in the right side, that is appropriate and same or equal to the left side. So that's why the critical value in the left side is minus. Okay, we just say this is what, this is the minus value, this is the minus value. Okay, now just you should use the find out the t value using this t statistic function. Okay, in this function equal sign, first you should take the standard deviation, this is the mean value, right? And then from the mean you should minus the hypothesized mean, which is 7 simply, and then this should be divided by the value of standard deviation, and this should be divided by square root of the sample size, which is 10 simply, and this is the t value. Look here students, since the t value is less than the critical value, right, it's mean we are rejecting the null hypothesis. Why? Because the critical value is minus 1.88 and the t value is lesser than t value. It means this is in the alpha, the significance level, or this is in the left side beyond the confidence interval area, dear students. So that's why comparing these two values, we are rejecting the null hypothesis. Why? Because the t value that is way less than the critical value. Okay, let me just practically show you have what is left tail. Okay, look dear students, this is the example of, okay, this is, we have t normal distribution. Okay, this is normal distribution, and this, okay, you can see the central value is here. Okay, this is the central value here, as you can see, the 7 hypothesized mean is here, and the critical region, this is the critical region, this is the 95% confidence interval, this is this place. Okay, okay, and this is the critical region, and this is the 5 significance level of 0.05. You can say this is 0.05 or 5%. Okay, and this is the critical region. The critical region, this is minus 1.8, right, and 8. And what is the t value? T value is even more here, okay, in this area, you can say in this place. So you can say the t value is far more away from the standard, from the hypothesized mean. From this value, from the center, the t value is so much farther. It is not in this confidence area. So that is why once the t value is above the critical region, or it is in this 0.05 area, you can say it's less than p value, p-value is less than 0.05, then we are rejecting the null hypothesis. Hopefully this is clear.